Hello there and welcome back to our second video. In our previous video, we looked at setting up our project for building an expression evaluator. If you've not seen the first video, you can see the linked video on the top right. So in our today's video, we'll be focusing on building the Lexer itself. In our last video, we built this REPL whereby the user could just input any commands and we'll just print them out. In this video, we'll focus so much on taking the user input and breaking it down into tokens. And at the end of the video, we should be able to have a vector of tokens that the user can actually see. In short, to be able to figure out what's a number, what's a string, what's an operator, and things like that. So to do that, let's go now into our include, and then I'll be able to go to the front end and then into Lexer. Now let's create a class called Lexer, and our Lexer class this will be the entry point into the lexing process and doing the tokenization. So first, let's define the kind of tokens we need to be working with. So let me create an enum. So I will do here enum. I'll make it class type, and then I will just call it token type. And in this enum, let's define all the tokens we need to support for this particular level. I'll prefix all my tokens by the word TOK. And then, so first and foremost, let's support number literals and then string literals. And then we shall also support identifiers. Identifiers are basically things to do like keywords, variable names, function names, and whatnot. So all that we'll just call them identifiers. So let me start by doing number or numbers, or whichever. And then we shall also do talk string. We just prefix them by literal here. So you feel free to name them how you feel more confident to do. So we have numbers. Now we'll also do Boolean literals. So that is true and false. We'll explicitly support them within the language itself. And then next, I want us to support null values. So I'll just do, let me just save it as literal as well. So that covers the literal. So we need also to have identifiers. I'll just call it ident. Let me just put, I'm not sure it's actually a literal per se, but let me just leave it at that. And then for a second category, let's now support the mathematical operators. So I will do talk add, and I will do this as an operator. I'll do talk minus as an operator. Also do talk divide, an operator. I think I'm missing multiply operator. And then at the end of them all, I need to have a token called end of file, just to mark we no longer have any more tokens to pass, so we are at the end of the file. So with this set, I think I will shorten this to just div. I'll do subtract, yeah. So add, subtract, divide, multiply. Think you also have other operators like modulus, power. We'll be adding some of those as maybe later once you have finished this part. Maybe one of the other things to consider at this stage is open parentheses. So this is this symbol, and then also have the token for close parentheses. So that is the other symbol. So we might have other things like maybe commas, colons, and things like that. We'll add them as we see the need to kind of incorporate them. Now, since we have the token types, let's now create a token class itself, a token structure. So for the structure for the token itself, I'll just call it token. And then the first parameter here should be the token type. And I will just call it type for now. The second thing we need to store here is the actual value we've got from the user. So if you are saying it's a token, maybe it's an identifier, what did the user actually pass in? So we need to store it as a string. So we'll do here string. And let me call it value. I can just call it value. And I think we need to import std string. So we just need to do here #include std string, and that will sort that out. So we need a comma here. There are other things we can kind of track, but they're not really important for this particular stage, and that is the position for our individual tokens. So if you have, let's say, a number, at what line, what column, what cursor, things like that. So you can also store them within the token itself, and that will be good for debugging purposes and tracking where these errors were coming from. But for our case, since we only be working with a single line string commands, I don't think it's necessary for now, but maybe once you're done with the whole to the interpreter level, we'll come back and add more functionality. Now, in our Lexer class, I think we don't need to worry so much about the constructor, so we can mark it as default. Let the compiler do the default constructor for us. What might be interesting for us is to create a Lexer class. Maybe let's just call it tokenize. And tokenize will take in a string user input, and it will return for us a std vector of tokens, as simple as that. So we'll do here std vector of token, and I will just call this method tokenize, and this will take a const reference to the string, and I'll just call it maybe source. That's the user source source string. Vector is complaining, of course, so we need to come back here and include std vector. That's what we need, and that should be sorted. So this will take the source string and return for us the vector of tokens. I'll be storing this one as part of the member variables. So let's add the public access here, and then for the private here, I will start and just call it maybe m tokens. I'll prefix all my private members or member variables with m underscore. So this is what we shall be returning the user, and I think we can give the user a reference to it. So a const reference to it. Good. Now, a couple of methods we need to implement, and I'll be walking you through them. I'll make them private for now, but let's do a method that returns a car, and just is called a pick method. The pick method will return the current character and the current cursor value. So let me just come back here and define underscore cursor. I think I will start it at 0. So the cursor will be what's the current character we are considering in our input string, as simple as that. So it will be index based from 0 and to the maximum size of the string. So next, I think I will also do, let me capture the user input into this class, and I will call it m underscore src. So we'll be assigning the user input here to this m src. So the other method we need to also have here is called advance. So same to It is same to pick, but now it will return the current cursor value and then increment the cursor to the next value. As simple as that. Another one I will want to implement is called end of file. This will help us know if maybe you are out of bounds, to avoid us getting errors to do with accessing indexes outside the range for maybe the array itself. What else we need to implement here? So let's implement these ones first. So I think I will save this file first, and then we'll go to the lexer.cpp file to kind of implement the whole thing. So let me just get these methods, and then I'll come to lexer.cpp. What we need to do here is to include, so we can go back to two levels, and then we can do includes, we can do expression evaluator, we can do Lexer, we can do front end, we can now do Lexer. Good. So with that in, we need to implement these methods, and remember they are also part of the Lexer class, so we need to prefix here with that. Next is for this one. So let me just prefix it Lexer here. Good. So just formatting. Now let's begin from our tokenize class, and I will just do the basic setup. So if you call tokenize, then I will first assign the string you're passing from the user to the m_src. Similarly, I will reset the cursor back to 0 in case we had already incremented it before. At the end of this class, I will be returning the m_tokens. It should be tokens, not tokens. So let me go back to lexer.h, and I think I will fix it to tokens here. And then what else? Yeah, that's enough. Good. So let me close some of these other files. So in our CMake file, let's also add the token, the lexer.cpp. I think that should be front end. And then we'll do lexer.cpp. Good. And then also in our main.cpp, let's include it here. Include back to includes. We'll do expression evaluator, we'll do front end, we'll do Lexer. Good. So with that in, so we'll come into maybe outside the infinite loop here. I will create a Lexer instance. I just call it Lexer. And then inside this down here, I will call Lexer.tokenize, and I will pass it the input that the user has actually passed in. And since this actually returns an array of tokens, so we can do tokens, and then to visualize all this, then we need to implement maybe a logging for these tokens to basically loop over all the tokens and just dump them out. But we'll be shortly back. Let's go back to Lexer first. So in our CPP file, let's implement pick. And I said just pick returns the source at the current cursor value. as simple as that. Same to advanced, so this will just return source at the current cursor value, and then we increment the cursor thereafter. For the EOF, this will just return m cursor if is greater than or equal to dot size, so that we have the size functionality. Good. Yeah. So if the current index is equal to the size of the whole input string or greater than it, then you already passed the end of the file. So we return true here. This will help us prevent us from going over the size. Now inside tokenize method, let's create a new infinite loop. Not really infinite per se, but the condition here will be as long as we are not at the end of the file. Let's do our work here. Now, so what we need to do is that we need to go over each and every character in the user input, and then figure out if the character is maybe a number, is a string, is a space, and based on those conditions, we can determine how to tokenize the input now. So for numbers, we need to first of all, let's have an if condition here, and we'll do pick because the current cursor value is at the value of 0. So pick will return us the character at index 0. And so we need to check if pick, I think it's usually std is number. That should be the good. Not is num, it's actually supposed to is digit. Yeah, I think I got that wrong. So if the current character is a digit, then we need to tokenize numbers here. So we don't have this method yet, but we'll be implementing it shortly. So if by any chance we reach here, we can just throw and say std runtime error, just call it unknown character, and then I can do that in the input string. So let's format this by using the std format. So this comes with C++20, but if you're using something newer, you can still import FMT into your project and work with it. And I'll just do your pick. Good. So let's also include here format, and then let's implement this method. So let's come back to the header. So I will implement these methods as private, and all of them will be void. Simple as that. Let's come back to here, and then I'll come down to here. I do void. So we need to build a number. So let's begin first as an empty string called maybe just num. Then what we need to do is we need to continuously read as long as it's still a number. But remember also that things to do with decimal numbers have a point in between somewhere. So let's first focus on integer numbers. So I will do, as long as we are not at the end of the file, and then 2, so we need to do here Lexer, and then also as long as is std is digit, and the digit is on pick, I think for the locale issues, let's not worry about them right now. So as long as we are not at the end of the file, and then we are still having digits within the input string. So what we need to do, we need to add the current value into the string called num, and then you advance the cursor to the next value. So if you encounter maybe an alphabetical character like A, B, C, D, it will kind of exit from this loop. So for this number we have, then we need to add it, create the token and add the token into our array of tokens. So we'll come and do here m_tokens dot maybe m place back. And then for this, I need to pass in 2 things, or even 3 things. So let me go back to lexer.h and come back to my token class. For my token class, let's create a constructor for it. And this constructor will take it will take three things. It will first take the token type itself that we have, and then because maybe I'm a bit lazy, I will still pass in the token type in string format, and then I will also pass in the value from the user. Yeah, those 3 things. So then I will do here token type, I'll do here type, and then I will do here std string. I also call it let me call it name, and then I will pass it another std string, and I will call it value. Let me just prefix them that way, and then let me add name here, and then we can then do, let's initialize this data using these ones. That's an easier way. So I can do type, and I pass in the type here. I can also do name underscore name. I can do value underscore value. Good, and that's it. So with that constructor done, so I can come back here and say token type, let's call it token number. I think I will still do token number. And then I will pass in num. So this will create the token value and add it into the array automatically by calling the constructor of this data. And that's it. So we'll have this already within it. So let me save my file. So to visualize it, I can come back here, and then I can iterate. I can do for const auto const reference, and I just do maybe token in tokens, and then for each token I can do, okay, I can just do some std cout, and so we need to, I can format the string actually to make it maybe, yeah, I can do here token, and then I will do dot type. So I'll be printing the string value itself. So let me do that, and then I will do dot value. So let me also enclose the type itself in quotation. This is just for debugging purposes. And then also we need a new line here, but not, okay. So I'll then pass the token.name and then the token.value. Good. So we need to also include format here. So I think Langdi is just complaining that it can't find format. So let me exit from this and good. I think that's a Windows command, not a Linux command. Okay. So let's rebuild this and so it's complaining a lot. So let me just confirm. Okay, I know why. So I think, let me just use square brackets for now. That way. I'll escape. Let me rebuild again. So in main.cpp line 22, we expect a semicolon after. Oh, that should not be there. Good, let's rebuild again. Good, we are good to go. So let's run it. So let's do 1 plus 1. So just do 1 first. So it shows you 1 here, which should not be so. Okay. Think I'm missing something. So we're appending it here. So let's go back. So in our while loop here, we should be checking as long as we are not at the end, not as long as we are at the end, as long as we are not at the end. So that means you are never getting into this loop as well as this one. So let me invert them. Yeah, as long as you are not at the end of the file, and then we are getting a digit here. Okay, so that's the issue. I keep forgetting the commands here. Let me rebuild it. Let me run it again. Let's even do plus. Good, we're getting now an error. Good. So let me run it again. Let me just do 1. So when you pass it a 1, you get a token of type numbers, and then the value is 1. So any number you give it, you should be able to get it correctly. So the only issue now being that it's actually remembering the previous, tokens, as you can see here. But that's not an issue. That's not an issue for now. So let's implement. The next one we need to implement is strings. And there are 2 types of strings. We have strings which have a single quote, and you have those which are double quoted. So for our case, we can work with maybe double quoted for now. So I'll come back here to the Lexer.h. Similar to this method, I will add another method, and this will be intended to pass strings. So let me just that way. So I will copy that here. So after numbers, I think actually what we can do is that we can copy the whole thing out, because it has similar functionality kind of. So I will copy this block. So let me copy it, and then I can paste it here, and then let me fix that, and then here I can call it string. So similar here, rename it to string, and then this is string. Good. So the only difference now being that remember that strings start with quotation mark. So in our if condition here, so we need to ensure that the first character is an opening quotation mark. So to do that, we need to check if pick is equal to the opening quotation mark. So we don't need that. Oh, sorry. Good. So if we encounter an opening quotation mark, then automatically we assume we want to parse a string. So, but we don't care so much about the quotations around the string itself. So we need to discard all those quotation marks before and at the end of the string. So to do that, what we need to do is inside this tokenized string, once we come in here, we need first to advance. So advance will move the cursor to the next value. That means you are discarding the opening quotation mark. And then next, we need to check we are not at the end of the string, and then at the second time, and then as well we need to check that we don't encounter the closing quotation mark. So as long as you're not at the end of the file, do this thing, and then at the same time, as long as we don't encounter the closing quotation mark. So we have consumed the opening quotation mark of a string. Also, we need to collect everything between the opening and the closing, discarding the closing quotation mark. So at this particular time, if we encounter the closing quotation mark, this loop will break and will move down here. The only issue now is that we also need to discard the closing quotation mark. But what if the user does not close the string? So down here, I will add a new method and I will call the method expect. And expect will maybe take the token we need to check, and in return it will take the token or the character we need to check and the error message to display to the user. So to do that, I'll pass in the quotation mark that way. At the same time, I also pass in the error message. I'll do here expected. I will do single quote. Oh, I need to escape it to close the string. So let's implement this method called expect because we don't have it yet. So I'll come back here, and then after EOF, I will add a new method called, it will be void type. I'll just call it expect. What expect will do, one, it will take a char, which is the current or the expected character at that particular point, and then it also take a const reference of an error string. Oh, this should be std. Good. So that's what we'll be expecting. So if you come back to lexer.cpp, after the pick method down here, or EOF, let's add our method called expect, and then this part of the Lexer class, so it's a member function, and then if you're not at the end of the file and the current character matches what you expected, we advance and return. If that's not the case, let's just throw an error and I will pass in the string we have, and that's it. So if this condition is true, we consume that particular character, and then we exit. So This will consume the closing quotation mark if it's found. If it's not found, we throw this error. So as simple as that, and then we add this string. So there's an issue with this logic at the moment, and I think I will show you where it is. So let's save our file, and then let's run our code. So let me just do here exit. Let me clear it. Good. So in our case, if now we do 1, 2, 3, we get number. I think now we are erroring out. Yes. So this should be else. So if this is true, we execute that and then we go the next loop to the first one again. So the issue is that we're executing this and then executing the next one as well. So that was my mistake. Okay, let's rerun this again. No, I wanted to build and run. So 1, 2, 3 should give you a token, good, a token number. So at the same time, we do hello. So we are expecting the closing quotation mark. No, then the file at the same time, the current character is I see. My bad. So we are not at the end of the file and the current character is not equal to a closing quotation mark. Yes. That's my mistake. So let's rerun our program again. So that means if we do hello. Good. So we get the string hello and then token type is string lit. So that means also if we forget to close it, we get this error thrown. Yeah, that's true. Now, one of the issues with this is that if I do hello and then I have an escape string and then I do world, we'll get an error. So within this passing of our string here in this block, we need also to factor in escaped characters like backslash quotation, but we are not going to be doing that at this particular stage. Maybe that will come in much later. So you have tokenized strings, you have tokenized numbers, and let's tokenize identifiers. And once we tokenize identifiers, at this particular point, we'll be able to handle all these two, the Boolean types and the null types as well. So let's come down here as well. Let's so think I will add those three, and then at this particular point, I will do tokenize identifiers. I'll do here tokenize tokenize also the operators. This will be called skip white spaces. So we'll be using these methods shortly. So let me just copy them into our implementation part of it. So after the tokenizing of our string, think down here, put them here, and then okay, good. So now that we've got the understanding of how to do, for the others is pretty much similar. So like for identifiers, I think I will just copy this block here, and then I will just paste it here. and then I will just rename this to ident. We'll remove that. So for identifiers, it's quite similar to how we passed numbers, but now identifiers have they can either be alphanumeric, that is alphabets A, B, C, D, 1, 2, 3, 4, 5, 6, 7, 8, 9, as well as underscores. So we need to factor in all that. So at this particular point, I will do if pick, it should be equal to underscore, or std is alphanumeric, and then I will pass it to pick. We can ignore the rest. And then I just rename this also to ident. We don't need to have the expect down here. Oh, we need to add this to Lexer, and that will be fixed. So as long as we are not at the end of the file, at the same time, we also need to group this so that the current pick value returns an underscore or is an alphanumeric. Alphanumeric is both for characters as well as numbers. So if any of this comes to true, we consume that value and add it to our identifier string. And then here we also do ident. So there's a small catch here though. So let me just put it that way first. Now, if we get some things like literals like true, false, and null, they're all part of identifier. So at this particular point, we need to check if maybe our ident is equal to true. If this is the case, or else if our ident is equal to false, so that can also be true. Else if our ident is equal to, let me use the nil, I like nil over null. So if all of these are false, then we'll be able now to add that one. So let me do this. And then at the end of it, we return. So in case this evaluates to true, sorry. So for this particular one, if it's true here, then we need to convert this to Boolean literal. Same to this. I think we can collapse these two into an OR condition. So if ident is true or false, they're both Boolean literal, so we can just do that. Else if it's nil, then we need to do here null. I will also do here null. I'll do here bool. So we also need to return to avoid. No need to return actually, because it's an if-else condition. Okay. So if it's true or false, we add a Boolean literal. If it's nil, we add a null literal. If it's none of this, it's an identifier. So similarly, let me also implement white spaces for now. So we'll do if pick. So we need to do std is space. There's a method called is space in std, and then you can do here pick, and then just ignore the local issues. So as long as we have a white space, we'll just do advance to consume the white space. Advance to consume it. So this is also part of Lexer. We need to add it that way. So as long as we have a white space, we advance and move on. For this also, let me just add the Lexer, or else the linker will complain shortly. So this will tokenize operators. We'll come to this next. So let me first incorporate the identifiers and white spaces here. So if it's not a string, so next here we also need to check for identifiers. So for identifiers, we need to do std is alphabetical on pick, because identifiers never start with by a number, so it should either be an alphabetical character or an underscore. So we'll do that, or pick is equals to underscore. So if that's the case, we tokenize identifiers. Identifier. What do you call the method? Tokenize identifiers. Good. And then next, as long as we're having some white spaces, is space. So if the current character is a white space, we consume all the white spaces until we get, and I will just, this is called skip white spaces. Oh, so this means we are missing a closing brace, parenthesis there. So this is, oh, no, so this is wrong. This should be here, and then, yeah. So, yeah, good. So if the pick is underscore or is alphabetical, then we tokenize identifiers. What am I really missing here? Okay, I think I was misspelling something. So for this case, we are capturing all the identifiers, white spaces, and the only thing we have not captured is mathematical operators for now. So let's save our file and let's build this. So now we can do X, and it will tell you X is an identifier. We can do true. It will tell you it's a Boolean literal. We can do false. It's similar. We can do nil. So if you do null, it will tell you it's just a normal identifier because we don't consider it as an inbuilt thing. If you do 1, it's still a number as expected. If you do x, bz, comma y, so all the white space are actually ignored. Good. So we've taken so much time kind of to lay out that foundation. So let's just finish first on operators. So it's quite similar. So I'll come down here, and I think at this particular point I will do that. So I will delete that particular line, and then I will just do else tokenize operators. So as long as it does not fall in any of these categories, I'll just do it to tokenize operators. And then let me just collapse all this identifiers. Okay, so here I'll put it here. For now we are only supporting single character operators, so maybe later when we'll be doing things like comparators, like greater or equal to, less or equal to, we'll be able to add more functionality into this particular method. But to beginners here, I will do, let's just do auto, and we just do op. So let's just call advance. Advance will return the operator itself, and then go advance the character to the next value, and then let's check here and do if op is equal to maybe plus. So if that's the case, we need to, so let me just copy this last line here. Maybe later we can refactor the whole thing down to make it much easier. And this will be op. And then this will be add. It will be add. Good. So it can either be plus or minus or multiply or divide. So this should be else condition, subtract, multiply. If we don't match any of this, then we'll just throw this error. So this should capture any other missing character that we might have. But we having an error here that we cannot create that. Okay, let me just build it for now. We'll see the error and figure out what it is. So clear the console, let's build and run. Let me see this error because okay, so I think I know why this error is being thrown, and it might be because of the last character here. So I think I might need to do std string here, and the same applies for the rest here. Not sure why I can't do that dynamically. Okay, anyway, it's expecting a string, but I'm passing a character. So that's what the error is trying to say in all these lines. Good, so we can now do 1 plus 1. So we get 1 plus 1. We can do 5 divided by 3. So let me move this Lexer. Let me just move it in here where it's being used. So this will avoid the issues to do with history to do with the previous command. So let's save. Let's exit this. Let's build and run again. So you do x times 3. So you get x times 3. So we can pass correctly. So we can even do students times 3. So you still get correctly students times 3. So if we pass in a character which maybe, we can even do underscore times underscore, and that will still work correctly, no issues passing. And this basically tells you that we can get now a list of our tokens from our class, but you are missing one crucial token. So let's go back to our Lexer. In our Lexer, we defined, so we have handled all this. We are only missing these two and the end of file. So let's start with the end of file. That's the simplest to add. In our Lexer loop here, so once we have been able to tokenize all the tokens and we are done, we need to just come back here and I think So we need just to come back here and add. So what you're adding here actually is an end of file. So this will be token end of file. So this will just basically mark that we are at the end of all our token stream. So yeah, and that's done for that. So the other one missing is opening and closing parentheses. So I can still even do here else if. So if you pick the current character is equal to opening parentheses, so we can copy this line and we can just basically do it here, and this will be open parentheses. Let me just as well put it here, and yeah. At the same time, if you find the closing parentheses, this will be the close. At the same time, this also will be the close. So this will allow us to group functionality. Maybe you want to show precedence of operations. We can use the opening parentheses to group some expressions to show that they should be evaluated first before we come to other things. And with that, that should be the end of our parser. So let's save our file. And now let's clear out and rebuild our program. So now we should be able to do 1 + 1 - 3. I see. So we are having an infinite loop, and I'll explain why. So whatever you're missing here is that let me there are two ways around it. Okay, let me just push these things into a new line. The first option, of course, is to convert this into a std string. I think I'm just going to use it, and then I will use advance here. So we are creating the same string, yes, but now we also advancing the cursor. So what we had, the issue we had was it was finding this, adding it into the tokens vector, but it was never advancing the cursor to the next value. So it was like an infinite loop. So I think that should be sorted. Let's rebuild it again. So let's even do 1 divided by 3 minus 4. So we have 1 divided by opening parentheses, 3 minus 4 closing parentheses. Then you have the end of file token. So this just marks that you're at the end of our token stream at this particular point. So this is what we call, this is actually the vector of tokens. That's what actually we're supposed now to pass into our parser. And our parser will be taking this vector of tokens and trying to figure out what is the order of operations for all these kind of things. Are we doing addition first, multiplication, division, maybe assignment, all those kind of things. So I hope you found this video insightful, and maybe you've learned one or two things. I'll be able to see in the next video where we'll now be building the parser and also generating the abstract syntax tree, the AST. And by the end of the next video, you should be able to have a similar output, yes, but now this time they should be order of precedence. And I'll be able to now start adding new libraries for us to work with to kind of have a better formatting down here. I'll see you in the next video. Bye.